All righty, we are starting our recording. Today is November 2nd. It is week 8 of NHA, which means we have 2 more weeks till our Thanksgiving vacay. Then we have 1 week off for the week of Thanksgiving, including both Tuesday and obviously Thursday of Thanksgiving. Then we come back for 3 Tuesdays, 3 Thursdays, and then we're off for 3 weeks, which means we have 5 more weeks left before semester ends, before winter break. 5 more weeks of teaching, 10 more lessons total, with a 1 week for the Thanksgiving week off. Do we have any questions about that? So we're doing 4 lessons per week with 5 weeks left. We'll get 20 more lessons. So we'll be right in the mid 50s range as far as when we're all said and done for the semester. Remember, first semester has 13 weeks and second semester has 15 weeks. So you can do the math. After 28 weeks, you can find out how many of these lessons we are going to do together. Lesson 31, my first class, I had a lot of trouble with my screen here, my computer, all those things. So much so I recorded it, but I might re-record it because I couldn't even do anything. And I was very frustrated. And I don't know if I want a recording of me being so frustrated on the YouTube channel. But it's all good. What do we think the word irrational means? Somebody give me a definition. Now, mathematically, it's actually a little bit different, but I want you to ask yourself what you think irrational means, and somebody give me a definition for what irrational means. Anybody? Okay, that's a good guess, Serenity. That's not exactly what it means here. There are imaginary numbers in math. What was that?
So like irrational numbers, so like 3 1/4 or 5/2, right?
Yeah.
Stuff
But
like
there's an actual, like when you think of irrational when it comes to, I'm giving out money. Anybody want money?
Why do you have $100 bills?
Because I'm giving it to my wife right now. She wants money. Was that? That's what he needs. Yeah, all that. It's like 137, so 140. Just no, not a tip. It knocks down our $3 next time. So, all right. Okay, sorry.
Isn't an irrational number like a number that can't be shown as a fraction?
Okay. Yeah, that's kind of a good definition of that. But we think irrational, like the word irrational, like if somebody is not making any sense, they're irrational. Like let's say you're debating somebody and their argument doesn't make any sense at all. That's irrational. Or somebody's behaving. So that's what the definition means kind of across the board in English. But in math, irrational means no ratio. And the reason it's no ratio is because fractions are done by ratios, but an irrational number is a number that goes on forever, either repeating, like 1/3 is 0.333 forever, or just a number that will never ever have an ending. For example, pi. By pi, I mean not the thing you eat at Thanksgiving, but the pi, 3.14. It doesn't end there. It goes on forever, basically. So when you say irrational number, the reason we're talking about that now is because we kind of introduced to you on Tuesday the idea of the radical sign. Now, the radical sign has the perfect squares, which you have of, 4, even 1, right? Or 9, or 16, or 25. Now, these are not irrational because each of these have an answer that ends, okay? But when you get to a number like 2, so if you take your handy dandy calculator, let me see if I can make this work. And we'll go to my calculator here. And I'm going to clear this off. Can you all see that calculator? Yes?
Yep.
Okay. So I'm going to go 2, and I'm going to see this button. Can you see my arrow also that's circling over that's hovering right now? Yes? Or can you not see my arrow?
Yeah, we can see it.
Okay,
We can
so
see
I'm gonna
it.
hit, this is just the square root of to the 2 root, which that's understood, okay? When I hit this button, I'm gonna have a number that'll be like 1 point something, and it'll take the entire rest of the digits that it gives you. Now, it doesn't stop there, and if I turn my, let me show you this. Let's hit it. Okay, so it's 1.4, 1, 1, 4, 2, 1, 3. It goes on forever. There's no way to make a fraction out of this because it never stops, right? So let me do this. If I do it on my regular calculator, and I go like this, you see it goes to like the 10,000 or the 100,000, the millionth place, whereas here we're in like the trillionth place, right? So you can see that it just goes on forever. So it's like repeating, but the reason they call it irrational is because there's no ratio involved. And that's where the approximate comes in. And I think I taught you all this before because you're in Algebra 2 now, and you probably learned this in Algebra 1, maybe even pre-algebra, depending on what curriculum you took. A lot of times we express numbers with this little, let me do it like this, like a squiggly line equal sign instead of a straight horizontal line. This basically means approximate, or it basically implies that you rounded. Because when you do with your computer, like when you do those square roots, you're going to round to some place because they go on forever. Pi we typically think of as 3.14 because, but it's, 22 over 7, right? Is pi as a fraction? Well, it's not even a rational fraction because it goes on forever. You can't rationalize it. And so you're basically even rounding when you're at a fraction, or 3 and 14 over 100. Again, those are going to go on forever. So that's what irrational means. So number 1 on page 31 problem set, it says an irrational number is a number that cannot be written precisely. The key there is precisely, because you have to round at some point, because you can't write forever because it will go on forever. As an integer, fraction, or decimal, positive or negative. Yes, that's true. The technical definition of a rational number is a non-repeating, non-terminating decimal. Now, again, for the repeating ones, yeah, so that's true also. So those two are both true, just trying to teach you a little bit about irrational numbers. Now, number 3 here, it says the Pythagorean theorem states the 3 sides of any right triangle have the following relationships. They have leg 1 squared plus leg 2 squared equals the hypotenuse squared. And we sometimes go a squared plus b squared equals c squared. This is basically the same thing. So that would be yes. The c squared has to be the hypotenuse. The hypotenuse is the side opposite the right angle. So this is a, b, c squared. Some of you have taken geometry, some of you not yet. We do a little bit more of the Pythagorean theorem in geometry than we do in Algebra 1 or Algebra 2, although we do it some in Algebra 1 and Algebra 2. It's the a squared plus b squared equals c squared is the, this here is the length of this side is this squared plus this squared equals that squared. And so anyways, so that'd be true. All 1, 2, and 3 are all true. Okay. So let's do this. How good are we so far? Are we okay? Makes sense? Just mumbo jumbo. You gotta learn mumbo jumbo.
Yeah.
Y'all like mumbo jumbo? Yeah. True story for those who jumped on right at 11. David McCumber comes on first. Actually, Bella was on first, and then David McCumber. And he changed his David to D-A-V-Y-D. And then David Sevchenko came on, and I thought, something's not right here. So that was well played by Bob the Builder. So, but now he's back to David with the I. If you all can see the participants. Can you all see the participants' names or no? Or just I
Yeah,
can't?
we can.
Oh, you
Yeah.
can see him. Okay, so, but now he's back to David with an I. That was well played, David. All right, let's do this. We're going to continue on the ones that have the 31 underneath them. But there's 10 and 11 both have this rational and irrational. Okay, so I want you to think through. Okay, a lot of times any radical root, we call them roots, but numbers of the radical sign or roots that are not perfect squares are going to be irrational. Or if they have, that should be third, I think. Third, so yeah, it doesn't matter. Or if they're to a bigger base, if that makes sense. So that being said, I want us to think this through. Is this rational or is it irrational? Now, if it's
Irrational.
rational, you can drop the radical sign completely and get a whole number integer. If it's not, you'll have a decimal that follows. Okay, so there's a couple different ways to do this, but you're asking yourself, is there any number multiplied by itself 3 times that exactly equals 8?
2.
2. So we would say that this then is rational because it has an answer that ends and it's not a decimal that goes on forever. Okay. Now, the number 10. There is, and by the way, you can't even pull anything out of 10 because there's another thing we know about radical signs is this. If you do a product of prime factorization and you have at least 2 terms that can come out, for example, if we have this term that's 20, we can actually pull something out of here, can't we? Because watch when we do a prime factor of do we understand that radical 20 is the same as 2 radical 5? Because you factor it, and by definition, anytime something appears, every second time it appears, it comes out once. Since there's 2 2s, they come out once. All right. You could also do it like this. You could reduce 20 to 4 times 5. And since this is a perfect square of 2, it comes out. The 5 doesn't come out. Okay. So you can reduce this to this, but the 10 doesn't reduce because nothing appears at least 2 times. Because by definition, the radical means something times itself. Since it factors to 2 and 5, you can't pull anything out. So it's just 10. Now watch what happens. So number 11 is this. Let me go to this. Let me go to my share. Go to my handy dandy calculator again. Let me clear this off. Then I'm going to go 10 square root. Now, we'll know that it's going to be 3 point something, right? How do we know it's going to be 3 point something?
Because 3 times 3 is 9, and 9 is pretty close to 10, so it's
Yeah. And then 4 times 4 is 16. And since 10 falls between 9 and 16, it's got to be 3 point something. And it's going to be on the lower end of the 3 point something because 10 is just 1 unit past 9. So you're absolutely right. So let's go get this. It's going to be 3 point something. I'm going to say 3. You guys think it's going to be 3.0 something or 3.1? I'm going to say 3.1. 3.1. That's what I'm going to say. Let's see what it is. 3.162277660168379. 10th, 100th, 1000th, 10,000th, 100,000th, millionth, 10th millionth, 100th millionth, billionth, 10th billionth, 100th billionth, trillionth, 10th trillionth, 100th trillionth, quadrillionth. That's to the quadrillionth place, and it goes on forever. Okay. So we're just going to call all that to say we're going to call number 11 irrational because it goes on forever. Okay, here we go. From 1 to 5. 5 meaning you're lost. 1 meaning you're lost. 5 meaning you understand it. On the count of 3, what are we? Okay. 4s and 5s. Right. Okay. All right. So we're going to use square roots and things like that a little bit as well. So this is kind of still introduction a little bit. Let's look at number. Now, they're not going to actually teach us, I don't think, how to. I've actually done this before, how to solve square roots without a calculator. It is really, really, really difficult. I'm not even going to try to teach you that. So what we're going to do is this. We're just simply going to use our calculator, and we're going to find what these numbers are for number 12 and number 13. So let's go and let's go to back to our calculator. So all we do here is this. We say 7, and since there is no little number, like postscripted number above the radical sign, here it has it. Okay, see a little 3 in that one, but this doesn't have it, so it's just to the 2. So I'm going to do this one right here that's just to the 2, and it's going to be, again, it's going to be less than 3 but greater than 2. It's going to be 2 point something. So it's 2.645. Okay, now they're saying they want it to go to the 100th place, round the decimal to the estimate to the 100th. So we're going to say 2.64, and this is 3rd grade now, rounding rules. We go to one place value to the right of the one in question. So here's the 100th. So we go one more to the 1,000th place. If this is 5, 6, 7, 8, or 9, it rounds this up 1. So because this is 5, this 4 will turn a 5. We've rounded up to 2.65. So our answer to number 12 is 2.65. Right? So radical 7 is equal to, not equal to, I'm sorry, is rounded to, we'll use squiggly equal signs, 2.65. The squiggly lines are basically saying I rounded that dude and I did not, it's not equal. So instead of saying equals, we say approximate. Okay. Number 13, same thing. It's going to be, again, between 3 and 4 because the perfect square 9 is 3. The perfect square 16 is 4. So because 11 falls between, again, let me show you. I think you know this, but watch. When I say 9 square root, just say 3. Okay. When I say 16, it'll be 4. And since 11 falls between 9 and 16, or the perfect squares of 3 and 4, this is going to be 3 point something. And it's 3.316. So the 6 will round this to a 2. 3.32 will be our answer. Okay. All right. That being said, I got 5 minutes. I will do one more problem for you on the page. Whichever problem you want to be done, let me know. Then we'll turn the page over and do the next side.
Number 9.
Number 9. Okay. Okay. So the first thing we're going to do on number 9 is we are going to, and I do have an answer key. I have not seen it yet, but I'll double check to make sure I'm right. So I have 9.1 times 10 to the 3rd power over 1.7 to, oh, I'm sorry, 1.7 times 10 to the 5th. You get that right? 1.7 times 10 to the 5th power, 2 times 10 to the 10th power. Okay, so what I'm gonna do is this. I'm gonna first multiply the 2 times the 1.7. 2 times 7. 3.4. Okay, which make I should have done that in my head. I feel so dumb that I didn't do that in my head. You add these times 10 to the 15th power. Okay, so now I'm going to take, so now I've taken these two, I've multiplied this times this to get 3.4. I've added the 5 and the 10 because that's what you do when you multiply exponents, you add them. So 10 plus 5 is 15. That's a 5 there. I know my writing is not the most legible in all the world. So I've reduced this all to this right here. Now I'm going to divide 9 by 3.4. Because by definition, a fraction means division. So 9 divided by 3.4 equals 2.6. They want me to go just to the 100th place. So it's going to be 2.65. Okay. So times 10. I'm just going to go 3 minus 15. And again, you're not supposed to have negative exponents, but in this context, you can for scientific notation, because scientific notation is actually expressing very large values or very small values. So the negative exponent is a little bit different in that regards because of the 10 base as opposed to other negative exponents. So that'd be negative 12. So my answer should be 2.65 times 10 to the negative 12th power, and I will double check it to make sure that we are correct. And I'm 97% sure I'm correct. Well, let me see what I did wrong. It says 2.68, not 2.65 times 10 to the negative 12th power. So maybe I multiplied wrong. Maybe I divided wrong. Let me make sure. Yeah, they just rounded differently. I mean, they put 2.68. I put 2.65. It says round the number part to 2 decimal places to the hundredths. And so they have 2.68. I have 2.65. They must have rounded earlier than me. And that's where approximate comes in, because where you round and when you round does have slight changes in the values. But again, yeah. So that's the answer to number 9. Anybody else have? Let's go to this. Let's go to the other side. Okay. Let's go to the next page here. I would like to see when they did that. I'll look at that, see why they rounded earlier than I rounded to get that off in the 100th place by a couple digits. I think they did it wrong. I think I did it right. So that's just me though. Let's look at number 5. Okay. On number 5, this is what you do. If you have, let me show you 2 things, mathematically speaking. And then I'll show you why it's this way. Okay, this is what we learned in pre-algebra, right? When you add variables, provided they're exactly the same, you simply add the coefficients together. 2 plus 3 equals 5x, right? Same rule applies for radicals. In order to add radicals, they have to be exactly the same, just like the variables. Then you just add the 2 there. Okay. If you had 2x plus 3b, you couldn't add those together. If you had 2 radical 2 plus 2 radical 3, you could not add those together. The outsides are the same, but the insides are different. Okay, so that's the rules on adding or subtracting with radicals, with roots, with square roots. Okay? But now they want us to multiply. Now we know when we have 2x times 3x will be 6x squared, right? Because we go 2 times 3, 6, x times x is x squared. Okay, similar principle in multiplying or dividing when you have radicals. I have radical 5 times radical 7. I just go 5 times 7 is 35. Then if I can reduce that, I will do that. But if I can't reduce it at all. 35 is not a perfect square. So 35, radical 35 should be our answer. If they want us to turn it into a decimal, we just go 35 square root 5.91. Let me see which one of those they want us to do. I'm going to double check for us. Don't want to use a stray. I think they want just 35. That's my guess. That's my guess. Yeah, they just want it as 35. So, yeah. Probably should have looked beforehand, but I know how to do these things. So, here's your answer. This is number 5 on page 145. Just radical 35. That's it. Boom. Okay. Let's do number 7. Okay. Who thinks they want to guess an answer for number 7? Tell me what you think it is. Anybody? Don't overthink it. Number 7 on lesson 32. Anybody?
5.
Okay, 5 what?
Radical 5, or like the 5 inside the radical sign.
Yep, radical 5. Perfect. So that's exactly right. Radical 5. That's all you're doing. Because watch, you're saying radical 10 divided by radical 2. 10 divided by 2 is 5. Our answer is radical 5. And that would be our final answer. So, all right. Number 9. Again, we want to do the ones with the 32s below them to start with, because those are the ones that are part of the lesson for the day. So since number 9 also has a 32 below it, it has radical 4 times radical 9, but to the root of 3 to the cubed power. Okay. Who thinks they know the answer to this? You can't really say it. You gotta. By the way, if it looked like this, our answer would just be 6. Because you can either reduce it beforehand and go 2 times 3, because the square root of 4 is 2, the square root of 9 is 3, 2 times 3 is 6, or you could go radical 36, which is equal to 6. Either of those would work, right? But you have this 3 here, so you can't do it that way. So this is not the answer to number 9. I'm just showing you if it didn't have these 3's here, it would come out cleanly. But here it does have these 3's, so it can't come out cleanly. So it's 36 radical 3. 9 times 4 is 36. If you wanted to, you could try to reduce the 36, but you would see it has to have 3 occurrences of something, prime factor, and the product of 36 and its prime factors is 2 times 2 times 3 times 3. And because of this 3, you have to have something appear at least 3 times to come out once. So this will be our final answer for number 9. All right. On those 3 that we just did, scale of 1 to 5, where are we? On the count of 3. 1, 2, 3.
4.
Okay, got a 4, got another 4.
4.
Anybody a 1 or a 2? Okay, so let's now go to number 13. Okay, number 13. So watch, what we're going to do is this. We have a fraction of 1 over 4 radical. Okay, now in math, when you see this radical over a fraction, the best thing to do is to rewrite it like this. The reason being, and you can't have when a final answer, you can't have a radical sign in a denominator, just like you can't have a negative denominator. So those are just mathematical principles. We're still solving it though. So this is number 13. So I take this radical 1/4 and I turn it to 1 radical over 4 radical, or the root of 1 root of 4. I like to say radical. That's probably not the best term. So if you ever hear me say that, I mean root. This is called a radical sign, but this is a root 1, better term. So we ask ourselves, is there something multiplied by itself that equals 1? And yes, there is. 1 times 1 is 1. So that comes out like that. Is there something times itself that equals 4 perfectly? Yes, there is. That would be 2. Okay. And now we have this 1. I've been able to drop the radical sign and drop the radical sign. So now I have just a half. And the half is 0.5 with no going on forever, no repeating, no non-terminating decimal. So I ask myself, number 13, they're asking me, tell whether each number below is rational or irrational. Because it ends at 0.5, this will be rational. Okay, you see how that is? Now, if it was 1/5, it would not be, because you have 1, 5. You'd actually have to multiply this by 5 like that to get rid of that as 5 over radical 5, and that would not work. Okay, so, but because it's a 4, and 4 is a perfect square, and 1 is a perfect square, we can pull it all out of this, and we get 1/2 as a final answer. And that's rational, because it's a clean ratio. Okay. Number 14. It looks like this. Okay. Because of this 4, there's nothing multiplied by itself evenly that would equal 25. So we're going to call this irrational. Let me pull my calculator out one more time and I'll show you. So number 14 is going to be irrational. And you'll see this on the calculator. Now, if it were just to the square root of 2, it would be clean because it'd be 5. Because watch, 25 with this radical 2 here is going to be 5, right? Because 5 times 5 is 25. Watch what happens when I go 25 to this right here, to the 4. I go this one here. I put the 4. Now what's going to happen is, what times itself 4 times? Well, 2 times 2 times 2, 2 times 2 times 2 times 2 is 16, right? 3 times 3 times 3 times 3 is 81. So it's going to be between 2 and 3, right? And it's going to go on forever. That you'll see why it's irrational. So it's going to be 2.2 something, I'm guessing. Let me press the equals. 2.236067977499979. Okay. So because I did 25 to the 4 power, it's going to be this right here. Anything times itself 4 times equals 25. Well, you're never going to get it perfect because it'll go on forever as a non-terminating decimal. And that means it'll actually be not equal to, but approximated at. Okay, so the answer to number 13 is it rational? Yes, it's rational, or rational, yes, because 1, 4 both come out and it is 1/2. The reason 14 is irrational is because 25 there's not any number multiplied by itself 4 times that perfectly equals 25. Not any whole number. It's a repeating decimal that goes on forever. Okay. Anybody have any questions? Let me just show you one more illustration to show you why these things are that way. So let's just take the number 20 again. And we're going to say, what's the square root of 20? 20 square root is 4.47. Okay. So let's just round this up to the 10th place, 4.5. Okay. So watch. I'm just showing you something right now. Hopefully this makes sense to you. So we're saying that radical 20 approximates at 4.5. Okay? Because we rounded up. Is that what we did? Is that way? Make sure I did that right. 20 radical. Let me do it. 20 squared. Yeah, 4.5. Because it was 4.47. And the 7 rounded the 4 to a 5. So the 10th place we approximate. So you see this little approximate. Remember, equals means the same on both sides. But watch what happens when I multiply 4.5 times 4.5. It's not going to be 20. It's 20.25. And 20.25 is not the same as 20. Okay? So that's why we use the approximate symbol, because it goes on forever, and I just wanted to show you that. So it's approximately that, but it's not exactly that. It equals means the same on both sides. Okay. Let's do this. We got about 5 minutes left. Let's go ahead and see which one you want me to do on page 145. You name it, I'll do it. Any number. Do your work for you. Thank you, Mr. Soto.
15.
15. Okay, perfect. They're asking if these two things are the same. So they have x squared minus 4x squared minus 6x. Okay, so now they're saying, is this the same as x minus 5 times x squared minus 4x minus 6? Okay, let's just multiply these together and see. This is x to the third power, actually. I'm sorry, x to the third power. Okay, let's multiply x squared minus 4x minus 6, x minus 5. Again, they're asking us, are these the same? This is in its reduced form. This has not been multiplied yet. This has been, so we're going to multiply these two together to see if it equals that. Negative 5 times negative 6 is positive 30. We already know it's not going to be the same, but I'll multiply it out just to humor you. Negative 5 times the negative 4x is a positive 20x. And then negative 5 times negative x squared is negative 5x squared. That's a plus, right? Yeah. Now we're going to have negative 6x. I'm just multiplying this by each spot. X times the negative 6 is negative 6x. X times the negative 4x is negative 4x squared. And then x times x squared is x to the third. So my final answer, I kind of got running out of room here, is x to the third minus 9x squared plus 14x plus 30. So no, they are not the same. Okay. That was number 15, asking us if those two are the same values. So this is in its simple form. I mean, you could factor x out of this. I get that. But this I'm going to actually multiply together, find out that this is my answer, and realizing that this is the answer, these two are not going to be the same. All right. So answer is no. Got time for one more. What you got? Going once. I'll do one of your problems for you. Going twice. All right. I guess we'll call that a day then. I could have done a problem for you. You must know how to do all these problems. And we'll let you go 7 minutes early. Actually, 2 minutes early because I usually get done at 11:45. So, anybody last minute questions? All righty then. We are going to let you go. All right. We will talk to you all later. We'll see you on Tuesday.
Thank you so much, Mr. Soto.